Welcome back, kiddies. Section 6.2. Today we're going to talk about using equations in slope-intercept forms. It's going to be very similar to what you did in Section 1. However, we're going to just add a couple twists in here. It's going to be just a little different, ask you to solve for a couple different things. So let's jump right into it. All right, so let's get started by doing a problem similar to what we started with last class. So given this verbal phrase, what we have is that if you haven't noticed already, that my packets are a little long, right? You know, notes-wise, practice problems. Gee, dang it, I wish I could just give you, right, no notes and no problems. You can just sit here and do nothing. That'd be just great. Not. Okay, but just for the sake of this, let's say Ramon grabs the third packet that I made and notices that it's 4 pages long. And he estimates that every 4 packets that I make, the length increases by 1 page. So the first packet I made that he notices was 4 pages. That means every other packet that I make is going to get bigger, bigger, bigger by 1 page. Okay, so first of all, if we think about filling in this table, we got to think about the two things. What are we talking about? Well, again, we're talking about the number of packets, right? Every 4 packets, it says, and then as well as the number of pages. So we really have two things we're talking about here, and that is packets and pages. So when we fill out this table, we got to think about those two things. Which one depends on the other? Which one's going to be my X? Which one's going to be my Y? Think about inputs and outputs. Well, the number of pages is really going to depend on the number of packets or which packet I'm talking about. So I'm going to put packets here. I'm going to write it as PCKT, packet, okay? And then I'll put pages here. So this is going to represent my X, and this is going to represent my Y. Packets, again, we'll talk about the number of packets, and same thing with pages. Units-wise, we'll talk about the number, not hashtag, but the number sign. All right, so given what we have, we know that the first packet that I made, or sorry, it says here grabs the, whoa, Nelly, the third packet that I made, not the first one, but the third one. Okay, that the third packet I made, I know it was 4 pages long. So unlike the other problem that I gave you the other day, we don't know how many pages my first packet was, but what we do know is that the third packet is 4 pages long. And it says every 4 packets, it's going to increase by a page. So, okay, let's think about this. Every 4 packets, well, that means this is going to jump up from 3 to 7 because that'd be the 4th next every 4 packets, you see what I'm saying? And it's going to increase by a page, so that's going to go to 5. Then 4 more, that would be 11. This is going to increase by 6. And then we look at the next one. This would be 15, and that would be the 7 pages. Okay, so this table shows, again, the number of packets or which packet I'm on and number of pages that packet would be. So now what we want to do is take and graph this. So remember that each of these represents a value of X and a value of Y. So what we can do is fill this out. So I'm going to put the number of packets, again, as my X-axis, and my Y represents the number of pages. So just like last time, I'm going to have to label my axes. So my X, I'm just going to go by 2. So I know I have 2, 4, 6, 8. Am I doing that right? 2, 4, 6, 8. Oh boy. 10, 12, 14. So I'm going every 2. Oh my God, this is just out of control. There's 14. And I'll go to 16 because I got to get to 15. So there we go. So then my Y, number of pages, is going, you see it starts at 4, goes to 7. So I'm going to go every other is 1. So I'm going to say 1, 2, 3, and then 4, and 5, 6. Oh boy, here we go. Pulling teeth, 7. Woo! All right, so therefore I just wanted to get the scale on there. So notice I just looked at my data, figured out what I wanted. Now I want to graph these things. Remember, each of these represents a point. So this would be a point of X is 3, Y is 4. So now I can plot this. When X is 3, Y is 4, that's going to be right there. And then the next one I have 7, 5. So 7 is going to be midway between 6 and 8. and 5 would be right there, okay? Then we have 11, which is going to be between 10 and 12, and 5. I'm sorry, 11 and 6, you dingus. Is going to be right there. And then the next one is going to be at 15, which would be between 14 and 16, and at 7 would be here. Okay, so now when I graph this line, here's the idea about today. Remember, we want to write, our goal is to write the equation. So from a graph, remember to write our equation, we need y equals mx plus b. So the two things we need is our initial value, which is our y-intercept, and we need our rate of change, which again is our slope labeled m. Okay, so we have to be able to determine these two values. So the slope should be easy. If I can graph this line, we can find the slope by going from point to point. So notice that this is going to go, and we can look at our table too, that the y is going to increase. My rise is going to be plus 1, and my run, the x, is going to be plus 4. So that means my slope is going to be 1, up 1, right 4. Okay? So in my equation, sorry, I had to blow off a piece of dog hair there. My slope here in my equation is going to be y equal 1/4 x plus b. Now I got to figure out what b is. Now the tricky part about this is that notice in your data, in your table, I didn't give you the initial value. Unlike the other problems where I tell you, okay, it starts off this long, like my first packet was so many pages, I told you right away my third packet. Now I can kind of see where it would be on the graph, but do I know exactly what that number is, right? Here's what I'm trying to say. Do I know what that y-intercept is? No. So that's what's going to be our problem for today, is how do we go about figuring out this y-intercept? All right, so to write the equation, we're going to have to follow the same steps that we did before. However, I'm going to add a little twist to it. So again, the first thing we want to do to write our equation in slope-intercept form, remember y equals mx plus b. The first thing we're going to do is solve for our slope. So again, to find a slope, you might have to look on the graph or use the formula y2 minus y1 over x2 minus x1. I might have to do that, or just read it on a graph, or maybe from a table as well. So you got to find the slope. Now the next thing is you have to find the y-intercept, and this is going to be the challenge today. The last video I showed you basically how to find it from a point, or we could also view it from a graph. Those kind of things were easy. Today you're going to get this new challenge. Okay? Well, when I give you a table or a bunch of points or even a graph, you are going to know a bunch of values of x and y. So if you don't know b, what you're going to have to do is solve for b. Because what you're going to have is you are going to have a point x and y, and you are also going to be able to determine your slope. So in your formula, you are going to have 1, 2, 3 of the 4 things you need, which allows you to solve for b. So what you're going to do is simply plug in a value of y and x, plug in your slope, and you're going to solve for b. Once you find b, then the last step again is to plug everything in and you'll have your equation. So let's take a look at our first example. First one, we're going to write an equation of a line that passes through this given point and a given slope. So here I give you the point of 5, 1, and my slope is 2. So here, if I just sketch a quick graph, okay, 5, 1 would be run, 2, 3, 4, 5 to the right, 1 up. Here's my point, and I know my slope is 2. So remember, the slope is 2 over 1. That would mean I'd go up 2, right 1. Now notice the issue. When I draw my line, okay, sketch the line between those 2 points, notice I don't know what that value is. And the thing is I don't want you to estimate it. I want to know the exact value. Okay, but think of the point 5, 1. This is a value of x, and this is a value of y. And then I also tell you that the slope m is equal to 2. So in my equation y equals mx plus b, all I'm going to do is plug these things in. What do I mean by that? Well, what's my y value? Well, my y value is 1 from my point. What's my slope m? My slope m is 2, so I can plug that in. Times, what's x? X is 5, so I can plug that in. And do I know b? No. So I'm going to leave b in the equation. And now notice b is the only thing I don't know, which means I can solve for it. So I'm going to go ahead and solve for b. How do I do that? Well, I'm going to say 1 is equal to 2 times 5, which is 10, plus b. I'd have to subtract 10 from that side, bring it over here, and I know that b is going to equal -9. 1 minus 10 is -9. I now know what b is. Okay? We saw from this, as I sketched it, I knew that it was going to be something in the negative, but I didn't know exactly where. Now I know exactly where it is by plugging in the information. So now I can finally write my equation. Y is going to equal, my slope is 2x minus 9. When I write my equation, I'm not going to plug in the numbers for y and x, but I'm going to leave y and x in there and just plug in my slope and my y-intercept. And there's my equation. Next one, we're going to write an equation of a line that passes through not 1 point in the slope, but now we have 2 points. So same thing again. Okay, I'm just going to sketch this, and I'm going to draw up a 3, 2 would be 3 to the right, 2 up. So that's going to be somewhere, whoa, that's a big, whoa, whoa, whoa. What is that? Get out of here. I hit the highlighter tool. 3, 2 is going to be something right there is my point. God, I can't draw a point today. And then 4, 9 would be something all the way up here. So again, this is just a sketch. But the whole point of this is that, oh my God, 2 points. I don't know where my y-intercept is going to be. Somewhere way down there, right? So the whole point of this now, again, is to solve for this. Now, you need 2 things. Y equals mx plus b. For your equation, you need the slope and the y-intercept. Notice in this problem, I don't give you either one. I give you an x. Why do I keep hitting that highlighter tool, kiddies? I give you an x and a y, and I give you an x and a y. I don't give you slope as well. So in this case, we have to use, in order to find the slope, we must find the slope through our slope formula, which represents, again, our difference between our y's and our difference between our x's. Hopefully you're getting used to this. So my y values, I have 9 and 2, so I'm going to do 9 minus 2 divided by my x values, which is 4 and 3, so divided by 4 minus 3. That's going to give me 9 minus 2 is 7. 4 minus 3 is 1, so I know my slope is 7. Okay? So now I know m is equal to 7. So how do I go about solving for b? Well, given here, you are given 2 points, 3, 2, and 4, 9. So remember, each of these represents an x and a y, an x and a y. So if I want to find the y-intercept, I'm going to take one of these points and plug it into my equation up here for y and x. Which one do I choose? In this case, it doesn't matter, so heck, I'll just choose the first one, because 3 and 2 seem to be easier numbers to work with. So my my y is 2, sorry. My m that I solved for is 7. Again, that was from right here. And my x is 3, and then I have plus b. Okay, so my goal again is to solve for b. So 2 is going to equal 7 times 3 is 21 plus b. I'm going to subtract 21 from that side, bring it over here. 2 minus 21 is going to be -19. That's going to equal b. And therefore that I know now my y-intercept is -19. Look at my graph. I know I just sketched this, but my y-intercept was way down there. -19 is way down there. So it matches. So now my equation would be y equals, plug in my slope of 7, plug in my y-intercept of -19, and I have 7x minus 19. Bada bing, bada boom. Okay, now write an equation from a graph. So notice this one, you might be saying, well, I could just estimate it, but look at this. If you look at that point, what is that? Is it exactly halfway down? I don't know. So in this case, I don't want you, again, to estimate the y-intercept. I want you to actually calculate it. Now, from a graph, again, we need our slope and our y-intercept. Y-intercept, I don't want you to estimate, so this we're going to have to solve for, but can I figure out my slope from this graph? Well, yes, I give you 2 points. So remember, the slope is rise over run, so I'm going to start from left to right, and I'm going to start from this point, go up 3, right 1, 2, 3, 4, 5, it looks like. So my slope is going to be 3 over 5. Now I'm going to take this slope, and I know here that I'm going to need, just like previous problems, a value of x and y. Where do I get that? Well, you now have a graph. So I can now take that point, for example, which is a point of 1, 0. And I can use that point and my equation, y equals mx plus b, slope-intercept form, and I can plug these things in. So my y is 0. My slope is 3 over 5 times 1 plus b. Okay, so again, I'm going to solve for b. Well, first of all, I have 0 equals, that's fine, but now I have 3 over 5 times 1. Well, anything times 1 is itself. So I have 0 equals 3 over 5 plus b. So I know, don't get freaked out by this, but it's just like a whole number. You just got to subtract 3/5 over, because you're adding those two things, and subtract it to the other side. So b is going to equal negative 3/5. So notice it's not exactly half as it looks, but we get a sassy little fraction. But now I know what b is. So I figured out my slope from the graph. I figured out my b from calculating it. So therefore, when I plug it into my equation, I'm going to have y equals 3 over 5x minus 3 over 5. And there's my equation. I know you got fractions there, but again, the whole point of this is you have to solve for b and not estimate b. All right, last example here that I'm going to go through with you. This is a word problem. So let's say I planted a maple tree, which I did in my backyard. After 4 years, it had grown to be 12 feet tall. And after 8 years, it has grown to be 18 feet tall, so a pretty big tree. So what I want you to do is I want you to write an equation that will model the growth of this tree. So again, the equation, what I'm talking about is y equals mx plus b. In order to figure that out, I need the slope and the y-intercept. So remember our slope. Well, we want to figure out how much it's changing. In this problem, does it tell me how many feet the tree is growing each year? Well, no, it doesn't. Does it also tell me b is the y-intercept, or the initial value? Does it tell me how tall it was when I first planted it? Again, no, it doesn't. But what I do tell you is really 2 points. After 4 years, it's 12 feet tall, and after 8 years, it's 18 feet tall. So really what I'm giving you is 2 points that represent the years and the feet that it grew. So if I want to write the equation, I'm going to have to do the same thing as I believe it was example 2. Find the slope and the y-intercept given these 2 points. So first thing I'm going to do is find the slope. So I'm going to take my y values, 18 minus 12, and divide it by my x values, which is 8 minus 4. Okay, 18 minus 12, let's see what that's going to give me 6. And 8 minus 4, let's see, 4. Okay, so let me simplify that. 6 over 4, I can divide each by 2, so that's going to be 3 over 2. So that means every 2 years, this tree is going to grow 2 feet. Okay. Now, how do I find my y-intercept? Well, again, I'm giving you 2 points, and I'm giving you, or we now found, I didn't give you, but we now found the slope. So what I'm going to do is take these things and plug it into my equation. I'm going to choose the 0.412 just because the values are smaller. So y is 12. My slope is 3 over 2, and my x is 4, and then I have plus b. And my goal, again, solve for b. Okay, I know we kind of freak out when we see fractions, but I have 3 over 2 times 4 over 1. Remember that? I can simplify across. That 2 will simplify to 1. The 4 will simplify to a 2. What I have as a result is 3 times 2. That's going to give me 12 equals 3 times 2 is 6. I can drop the over 1 because 6 over 1 is just 6. Last thing I need to do is subtract 6 from both sides, and my y-intercept is 6. What does this mean, my y-intercept being 6? That means the tree was 6 feet tall when I first planted it. Now I can write my equation. So my equation is y equals 3 over 2x plus 6. And this equation represents the height of the tree after so many years. Now again, what we can do is take this equation and use it. So I want to know how tall was the tree when I planted it. Well, interesting. Didn't I kind of already say that? Well, this would be my initial value, right? What is the initial, in this case, height of the tree? Well, my initial height is represented by my y-intercept. So I know that the initial height of the tree was 6 feet tall because that's what my y-intercept represents. Okay, so this is just a word problem and application, but notice it fits the types of examples we've done. All right, last 2 examples here. I want you to try these. First thing, notice that these are written in, oh my God, function notation. Think back to section 5 of last chapter. We need to be able to write these as points. So let me help you set these up. Remember when you see f of negative 2 equals negative 2, that this is x and this is y. So this technically gives you a point of -2, -2. F of 4 equals -8, same thing. This is x, that's y, so I give you 4, -8. So think about, how do you write the equation if I give you 2 points? Second one, we have a mapping diagram we learned way back when, but remember, a mapping diagram is very similar to a table. It matches x and f of x, which remember also represents y. So I'm giving you the values of y and the values of x. Think about how you can find the slope and the y-intercept from there. So give these a pause, see if you can figure it out. Otherwise, the solutions will pop up in just a second. Here we go. Give it a pause. Alrighty, take a look and see if you figured this out. Otherwise, I'll go through it relatively quick. Again, function notation, what I did is just took these function notation and wrote them as points, -2, 2, 4, -8. I had to take each of these points. First thing, calculate the slope. Again, using my slope formula, y2 minus y1 over x2 minus x1. I plugged in my y values of -8 and -2, divided by my x values of 4 and -2. Again, when you subtract negatives, I had to change the sign, turn to addition. I got -6 over 6, which is -1. Then, using my equation y equals mx plus b, I have to plug in a y and an x and plug in my slope. So I plugged in y and x of -2 and -2, so here and here, and I plugged in my slope of -1. I then solved and got b is -4. Once I have my slope and my y-intercept, I know the equation is going to be y equals -1x minus 4. So the only thing tricky there was function notation. The next one, the mapping diagram, again, is like a table. So this one, it went, if you look at the y's, it went down 2, and the x, it went up 4. So I can take that as my rise over my run, my change in y over my change in x. I then know my slope is going to be rise is down 2, and my run is plus 4. So -2 over 4, which simplifies to -1 over 2. Okay, the other way you could have done this again is you could have chosen 2 points and used the slope formula that you did over here. Okay, you can do it either way. Then what I had to do is I had to find the value of x and y to plug into my equation. Well, this whole table is a set of 4 different points. So I just chose 1, and it doesn't matter which one you choose. I chose 4, 1. And I took and I plugged that into my equation. 4, 1, I plugged 1 in for y, 4 in for x, and my slope of -1/2. I then simplified -1/2, half of 4 is 2, so I get -2. Then I added 2 over here, got b equals 3. So putting that together, my equation is -1/2 x plus 3. Okay, so today's lesson should be a little more challenging than what we've done in section 1. So again, if you have any questions, make sure you jot them down, bring them to class, and we'll go through all those things. Good luck on the practice problems, kiddies, and the mastery check, and we will see you next time. Peace.